basically what's happening now is that power is passing from the ground, which controls everything now, to the Vega onboard computers, which will control everything after liftoff. Under 2 minutes to go. Now, I know you're going to go outside and watch the launch. Before you go, just tell me what's going through your mind right now after all these years on the project.
I'm feeling quite emotional at the moment, and I don't know how I will react when I see it really going up. But it's such a long program, and let's see it going up.
All right, well, we'll get your reaction when you come back. Martin's going to go outside. You see the other people here in the hall going out on the 2 terraces on either side of the building here. Vega, you get a good shot of the launch pad, and they will see Vega rising up and going toward the north. Martin is going to be out there. He'll be back, don't know when, maybe after the separation of the first stage, maybe a little later. And we'll get his live reaction and his emotional reactions.
DDO, attention pour moins 1 minute.
DDO is going to announce the 1 minute mark now.
Top H0 moins 1 minute.
So we are into the final 60 seconds. Give us a chance to say hello to all our friends at Airbus Defence and Space in Les Mureaux, back in France, at ESA headquarters in Paris, Estec and Isaac and Esren, all of our industrial partners as well, as we look at the spectators gearing up for the liftoff. To all of you watching on the internet, also we all hope you're enjoying the evening. We're going to cut away and let you enjoy the liftoff. You will hear the DDO call out the final 10 seconds and we'll be underway. Enjoy the liftoff, everyone.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80 et décollage VV12 Aeolus. La propulsion est nominale. La trajectoire est nominale, la propulsion du P80 est nominale.
The DDO says all is fine on board. You saw Vega take off like a shot. I'm always amazed. It took her about 3 seconds to cross my computer screen here. 3 seconds, rising like an arrow. Surprisingly fast if you're used to watching the Ariane 5 liftoff. Ariane 5, of course, raises into the air much more slowly, weighs 6 times what Vega does, carrying 4 times as much propellant. Fine shots of her rising into the light clouds. All is well on board, says the DDO. Vega weighing 138 tons at liftoff, as she lifts off from French Guiana, beginning the 12th mission in her career. They call her the light launcher at 138 tons, but I guess that's relative. The first stage is burning now. She weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant in any system that we're using today. The first stage burns its single engine for about 2 minutes before being jettisoned. Maybe we'll be able to see that as our camera is tracking Vega, because visibility is pretty good. First stage is produced in Colleferro near Rome, then delivered to the French Guiana plant here, where it's loaded with fuel and transferred to the booster integration building. You probably saw some of that on the video on the launcher campaign. And having returned with a big smile on his face, before separation, is Martin Kasper. So, how is it?
Incredible.
Tell us.
You see it, you feel it, and all the emotion that comes loose. It's great.
You're laughing.
No, it's not laughter. Yes, it's laughter, but also cry.
Did you cry? Did you shed a tear?
I did shed a tear.
That's good. What impressed you the most? The sound, the speed, the light, what?
The light was so bright. I had not expected that from such a small launcher.
Mm.
I saw the Galileo or the Ariane launch, but
yeah,
this was much brighter than I had expected.
It's like Times Square out there. You can read a newspaper. All right, very good. Come down and watch a launch, folks, if you haven't already. P80, first stage separation has come on time. The second stage is burning. We're into the second stage burn, called second stage the Z23, Z for Zefiro. burns its solid rocket motor for 86 seconds. Avio, of course, responsible for production, integration, and testing of both second and
Du
third
dogleg
stages.
et propulsion du Z23, parfaitement nominal.
Vega's launching north, going into a sun-synchronous orbit. Why do we need that sort of an orbit?
We need it for Aeolus, for the instrument for Aladdin. We want to have a dusk to dawn orbit, so that we're always in the sunlight, and it's also the best way to measure the wind profile.
And the orbit is called, they have a name for it, it's ball of yarn orbit, right? Explain that to us.
It is basically, you go north to south pole while the Earth is rotating underneath of you, and in this way you peel off the Earth completely.
You saw separation of the second stage. We're waiting for confirmation by the DDO of the third stage, ignition of the third stage.
Allumage
And there you are,
09.
right on time. And
Et
coming up next,
coiffe.
separation of the
Trajectoire
fairing.
nominale.
All right on time. We can separate the fairing now because we've made it out of the atmosphere. Now, exposed to the elements, on the right, the round white section, that's your baby.
The baby is the cubicle and the white part of it in total, yes.
So she needs no more protection from the atmosphere. She's getting her first taste of space.
Of space, but not the first taste of vacuum. She was tested in CSL Belgium.
Right, we have a story about that coming up. First, we're used to seeing, here's a question for you, commercial satellites, 15-year lifespan, maybe more. 3 years for Aeolus. Why is that?
Well, Aeolus is one of the
toujours
Earth
nominale.
explorers, and it's also a technology demonstrator. And because of the small size, we have less fuel on board than the telco satellites have.
Right. So how much fuel, roughly?
We have about 266 kilograms of fuel on board.
La propulsion du
Or a
Z09
free
est
emission.
nominale.
And the other thing is geostationary satellites are geostationary. They use less fuel to stay in orbit.
Now, why is that?
Because they are geostationary, so they've got...
Because they don't go round in
They
the
don't
ball of
go
yarn.
around. Exactly.
Okay, very good. Another question for you. Aeolus is riding inside the Avum, that's the upper stage. What is Aeolus doing now? I ask you because sometimes satellites are launched on internal power, sometimes they're not on internal power. There are two schools of thought, and there are advantages for both sides. What's the case today?
Well, for Aeolus, we are on internal power since about 10 minutes before launch. So we made sure that our baby is awake and running its own internal processes.
And what's the advantage to that?
The advantage is that we know that the spacecraft is on. You can also switch it on in orbit through telecommand. But then, if you miss it, it will not go on. The disadvantage of what we're doing now is that you're in internal power, so you're draining the battery.
You're using some of that power.
Exactly.
Yeah, but I guess there's a case to be made for both sides. That's a hot debate in the space industries, as I see it. Vega means, excuse my Italian, Vettore Europeo di Generazione Avanzata, or Advanced Generation European Vehicle. The light launcher is the newest member of the Ariane family. Coming up on separation of the third stage. There you are, right on time. Confirmation from the DDO. Now what's left of the composite? On the left, the triangular bit is the Avum, triangular white bit. The gold box in the middle is what?
That's what we call the platform. So that's basically containing all the equipment to keep the satellite in the right orbit.
And you can still see the composite on the right of your screen. And of course the spherical, the oval, white on the bottom is the...
telescope. The telescope, which is part of the instrument Aladdin.
Aladdin, very good. We'll have more on the instruments coming up later. We have been picked up by our downrange tracking stations. There's one here in Galileo. The next one is in the Bermuda Islands, where there's a NASA station. Bermuda will be tracking the launcher from the first Avum ignition to its cutoff on the first pass around the Earth.
Début de la manœuvre
See how we're going north?
avant le premier allumage de l'Avum.
You see the composite being spun up before the first ignition of the Avum. The first ignition, a long one, lasting about 8 minutes. There will be another one later on, a short one lasting about 20 seconds. Tell us about some of the other stations. I know there's some stations far north, Norway, Sweden, and Antarctica, that are going to be picking up the signal after the Bermuda station.
Yeah, so we have one telemetry station in Kiruna, Sweden. That is where we upload data for the control of the spacecraft. And then we've got two ground stations in...
There's the, while you're thinking, there's the beginning of the first Avon burn.
Okay, one is in Svalbard and the other one is in Troll, and there we download the science data from the spacecraft.
The Troll station in Antarctica will give us the final acquisition of the signal later on. Vega's history, briefly, it's interesting though. She grew out of an early US missile called Scout, you may remember. Italy used the Scout from the 60s through the 80s, and it flew 27 times.
Impressive.
Yeah. Launching originally from Wallops Island off Virginia, sort of on the flight path tonight, north over the east coast of the US. Then she launched from the San Marco platform off the coast of Kenya. This was an old oil platform, if you can believe that, on the equator. Kuru is near the equator. In 1992, Scout production was closed down, but the project continued as an Italian venture called the San Marco Scout, led by ASI, the Italian Space Agency, and Avio. So you see, Avio has been involved since the beginning.
La télémesure lanceur est bien reçue par la station de Bermude.
DDO says Bermuda is picking up the signal now. Our next film, a look at Aeolus close up.
In August, the European Space Agency will launch its latest Earth Explorer mission, Aeolus. The mission aims to further improve our understanding of winds and help increase the accuracy of weather forecasts. But this new satellite is unlike any other. For example, its shipment to Kuru is by boat rather than plane, because the sudden increase in atmospheric pressure upon landing could damage some of its delicate instruments. Aeolus is also the first space mission to acquire wind profiles on a global scale. This wind data is needed to create weather forecast and climate models. Today, meteorologists have to analyze winds by using weather balloons, tracking clouds, measuring temperature and looking at sea waves for surface winds. These methods, however, have severe limitations and give insufficient data.
All of these systems are not measuring all over the globe at all altitudes from the surface all the way up to the top of the atmosphere. And in order for the model to get the winds right, they need more observations. And this is where the Aeolus satellite will come in. Aeolus will measure winds from the surface or from optically thick clouds all the way up to 30 kilometers and filling a gap in the current observing system of the Earth for forecasts.
To detect these wind profiles from space, Aeolus uses a powerful laser called Aladdin, which stands for Atmospheric Laser Doppler Instrument. This instrument ejects an ultraviolet laser beam through the atmosphere. The air particles in the atmosphere, which are moving because of winds, reflect some of this light back to the spacecraft. By measuring the shifting frequency of this backscatter, Aeolus can detect the wind speed and profiles at different altitudes. Aeolus is the first satellite to use this technology in space. This is why its development has been a long and costly process. The satellite is both a technological marvel and a real challenge.
We pulse our optics 50 times every second, and this goes on year after year. And this intense pulse creates 1700 degrees on the optical surface of the optics and will fatigue the optics in long run. So we've had tremendous developments of the coatings of optics and to withstand this high pulse, laser pulse ability. We are actually our own sun, if I may say.
Despite its more than 16 years of development, Aeolus overcame all difficulties because the mission was of great importance to the scientific community, who have requested data on global wind profiles for the better part of 2 decades. Due to its low altitude, Aeolus will have a lifespan of only 3 years. However, ESA hopes the technology will be continued on similar satellites in the future, as the understanding of wind profiles is a key factor for meteorological and climate models which benefit us all.
During the film, we were picked up by the next downrange tracking station. You can see it on top, Saint-Hubert, a Royal Canadian Air Force station in Quebec, also used for Soyuz, by the way. It'll track Vega until the first AVUM cutoff. Now, Martin, in the film, they talked about 16 years development, overcoming difficulties. What sort of difficulties?
Well, at the beginning, we had a working laser on the table, and then we put it in the vacuum chamber, and it stopped working.
Bad news.
Bad news. So then it's okay. We all thought that this is the end of it.
What? The end of the project?
We thought the end of the project because we put the laser in the vacuum chamber, and within no time the laser stopped completely working.
So
So
you thought it was the end of the project. Everybody panicked. We'll find out what Martin's teams did to fix the situation after the next film on the prime contractor Airbus.
Il reste 2 minutes 30 de poussée de la VOUM et la propulsion est correcte. Et le pilotage est calme, tous les paramètres propulsifs sont normaux. Il reste 1 minute de propulsion de la VOUM.
So before the Airbus film, you were telling us the project looked like it was off a cliff. What happened? How'd you fix it?
well, we realized that the difference was ambient or vacuum, and that was the lack of oxygen. So we realized, wait a minute, maybe we need oxygen. We did a few tests, we applied oxygen, and guess what? It worked.
It worked. Now that was just one of many technical challenges. You mentioned some other ones that you had.
One of the things we had, we invented the in-situ cleaning system to supply oxygen, but no one had built that before. So we needed to find components that could do that. For instance, pressure transducers that work under high pressure oxygen, but also low pressure oxygen did not exist, so that all needed to be developed.
Now this because the Aeolus being part of the Earth Explorer system, or ESA, Earth Explorer missions always using
Extinction de la VOUM.
groundbreaking science,
We're all
never flown before. So this is part of the, must be very exciting, must be very frustrating.
it's always on the edge of technology. We're always on the
Et
boundary
début
of what
de
we
la
can achieve.
manœuvre d'orientation avant la phase balistique.
The upper stage engine, the AVUM, has shut down successfully after its first 8-minute burn.
L'orbite atteinte à la fin du
And you
premier
see
boost
the
à VOUM est
composite being spun
nominale.
up. Some of the benefits of Aeolus, we've been talking about them a little bit in the films. What's it going to bring to the average person?
But the benefits is that we will have much better weather prediction, so that we can, if there is let's say a high winds or a hurricane or something like this, we can better predict
Et fin de la
where to
manœuvre
put the
d'orientation.
resources in order to recover the situation.
This mission, the 120th satellite, built for launching by Arianespace by Airbus, getting back to them. 20 more Airbus spacecraft remain in the Arianespace manifest.
Phase balistique.
Fifth mission for Arianespace this year. We've flown 3 Ariane 5s and a Soyuz so far. The 299th launch for the Ariane family. Aeolus being the 27th satellite launched by Vega and the 583rd satellite launched by Arianespace. Some interesting numbers for you. Going back to orbits, our sun-synchronous orbit, most Earth observation satellites have to go into this orbit, heliosynchronous. Why is that?
It's, well, the thing is, you want to have a global coverage with Earth observation spacecraft. So then the only way to do it is with a polar orbit.
Because, why, does the sun light have anything to do with it?
No, that depends a bit on the mission. For us, for the measurements of the wind, it was necessary to be in the dusk to dawn.
We're going to go now to a replay of the liftoff. You can relive those very exciting moments. You see 3 seconds, and she's gone from the screen, as I mentioned. We have several observation sites across the space here, have cameras at most of them. They record the liftoff from their different angles. It's these shots you're seeing now. Many of the VIPs and invited guests are out there tonight. Have you seen a launch from there?
I just saw last in July the launch of the 4 Galileo spacecrafts.
And how does it compare with the one you just saw?
Yeah, completely different. I mean, the Ariane is much larger and slower, but the sound is more intense.
Yeah. And the sound from the launch base takes about 90 seconds to come here to where we are in Jupiter. Is it the same for the Vega? Because I've never seen...
No, it's less of a delay between what you see and what you hear.
Does that have anything to do with the Doppler effect, which you're going to talk about?
No, it's mainly the distance.
I'm confusing two things. Well, I'm no physicist. All right. Over the fine shots of the replay, we're going to say a temporary goodbye. We're going to cut away for about 20 minutes while Vega enters a ballistic phase, waiting for the second AVM ignition and the end of the mission after that. So enjoy the break. We'll be back at about plus 21 minutes. See you then. hope you're enjoying the evening. We're going to cut over.
Super, merci.
Great. Thank you for coming back to join us. We're still out on the terrace.
Coupe les ordres. Si je pars, sommes là, fidèle au rendez-vous,
We're
à plus 41 minutes et 20
post at
secondes.
41.22 seconds.
Vega a décollé il y a plus de 40 minutes. Et le sujet, bien, tout de suite, c'est avec
And
Alexandre
the
Dallonneau qui nous explique.
upcoming film that we're going to show you is a review of flight events.
We are now in the ballistic phase. To get us here, you saw that we lifted off on time 41 minutes ago. After liftoff, Vega's first stage, called the PAT, burned for just under 2 minutes, taking the launcher to 53 kilometers altitude. 1 second after its separation, the second stage, the Zefiro 23, took over burning for 1 minute and 40 seconds. When its engine finished burning, Vega was at 127 kilometers altitude. 40 seconds after, the Zefiro 9, the third stage, took over. Its engine burned for 2 minutes and 40 seconds, taking Vega to 213 kilometers when it separated. Its pitch on separation is normal because it allows Earth to better control the thrust. We are now at 6 minutes and 30 seconds after liftoff. A short ballistic phase of 90 seconds followed before the first AVOM ignition. Our speed, it was 703 kilometers per second. The first AVOM burn lasted 8.5 minutes. At the end of this burn, Vega was flying at 350 kilometers altitude. When then entered the ballistic phase, which lasted for 36.5 minutes. The long ballistic phase will end at H plus 53 minutes. The AVOM will be at 320 kilometers altitude. The second AVOM burn will circle Vega's orbit. It's a short, only 20 seconds roughly. Aeolus will separate from the AVOM at H plus 54 minutes and 57 seconds. Because of spacecraft mission specificities and its atmospheric laser Doppler instruments, Vega's trajectories was constrained in attitude throughout the flight, making it a complex mission. Vega is designed for such constraints, making it the perfect launch system for this kind of mission.
Merci à Alexandre
Thank you
Dallonneau pour
to
ce
Alexandre Dallonneau for this recapitulation of the mission. I'm still on the terrace, still seeing the setting suns. There are a few clouds and some red glow. We're going back to Jupiter with Josh.
We're still here on the inside. With me now, Joseph Aschbacher of ESA, the director of the Earth Observation Programs. Welcome.
Thank you.
We have 3 questions for you. First question, what are the Earth Explorers? Que sont les Earth Explorers?
Earth Explorers are one series of satellites which are dedicated to science. In fact, they are serving 2 purposes and are driven by 2 main objectives. One is to answer burning questions of science, and secondly, to explore new technology which has not been flown before and which is completely new. And Aeolus is the 5th of the Earth Explorers. We have already launched 4 of them.
Some of them here on the screen.
They're here on the screen, Goche, SMOS, Cryosat, and Swarm. So now the 5th one is Aeolus, and we keep still our fingers crossed that all goes perfectly well. But we also have some others in the pipeline, like Biomass, Flex, EarthCare, which are the next ones to be launched. So they're really addressing questions of science to better understand the Earth system as a whole.
How does Aeolus fit in globally to the ESA Earth Observation Programs? Quel est le rôle de Aeolus dans les programmes de l'observation de la Terre de l'ESA?
Aeolus is one of 25 missions which are under development in the Earth observation program. In addition, we have 14 missions in operation. So really we have a very strong portfolio of different missions, different satellites, either in development or in operation. So Aeolus is really the mission addressing very important questions which are relevant to society, better weather forecasts, better weather prediction, but also climate modeling is a key application. And it really is one element of a larger family, a larger group of satellites that do measure various parameters. I should say that the Earth Explorer family is the research mission, while we have also other families which are more geared towards operation, the Copernicus missions and meteorological missions.
Okay, how about the Sentinel missions? How does Aeolus fit into the Sentinel missions? Quel est le lien entre Aeolus et les missions Sentinel de l'ESA?
The Sentinel missions is a different type, different family of missions. They are operational missions. We are doing them with the European Union together. They are co-funded. The space component is co-funded by the European Commission and the European Space Agency. But they're really serving policy priorities of Europe, which are addressed with different parameters. We have launched today 7 out of the 20 Sentinels that are funded currently. And they really build up, I would call it the world's best, most ambitious Earth-observing system. I should also mention that in addition to the Sentinels, we have meteorological missions, which we are doing together with EUMETSAT, and we have the honor of having Alain Ratier with us today. We're also working, ESA and EUMETSAT, extremely well together in order to build geostationary and polar orbiting missions.
Okay, we're out of time. Josef Aschbacher from ESA. Many thanks.
Thank you very much.
We're going to go to a film now. What have we been talking about? The winds and the weather. We have a film on just that coming up. We'll be back with more. And the end of the mission and satellite separation. Don't go away.
Winds on our planet are created by the difference in temperature between the equatorial regions and the poles. They are the flow of air from high to low pressure. As warm air rises in the tropics, it flows towards the poles, where the air pressure is lower. On its way there, the air cools and sinks again, conversely leading to higher pressure and counterflows near the surface. This way, winds are basically redistributing heat energy over our planet. This process of energy redistribution, combined with the Earth's rotation, generates the weather patterns we experience every day and makes our planet habitable.
If we didn't have any winds in the atmosphere, then it would be very, very hot in the tropical regions and very, very cold in the northern regions. We would not be able to live in Europe because wind is a very effective transport of energy. It's similar to the draft in your house. When you open a window, you get flow in and change the temperature in the house. The wind have the same effect for the circulation. So that's the main reason for the wind.
Since the dawn of time, mankind has been trying to assess winds and predict the weather. Where in ancient times farmers had to consult soothsayers and oracles, today we have more modern ways of predicting the weather. This is the European Centre for Medium-Range Weather Forecasts in Reading, UK, a partner of ESA in the Aeolus programme. They make global numerical weather predictions based on in-situ and satellite measurements. Their forecasts include detailed weather predictions within the next 2 weeks, less detailed forecasts for the next month, and indications of likely trends up to a year ahead. These numerical predictions are the basis for weather reports worldwide, and they are important for society.
The reason why it's important for society is probably the most important reason is it can save lives because occasionally the weather is extreme. If we have extreme storms, and it's very important that we warn people about this in advance. So the more accurate we can make our forecasts, the earlier we can advise people to take action to avoid being involved in weather disasters.
In order to run weather models based on numerical weather prediction, it is important to have sufficient and accurate data on the current state of the atmosphere, such as global wind and temperature, as it is their interaction which drives our weather. Today, this data is mainly obtained via in situ measurements of weather balloons, ground stations and data from aeroplanes. Satellites are used to measure temperatures from space and track winds indirectly through cloud movement and wave movement on the ocean's surface. However, there remains a significant gap in wind data over vast land areas, the oceans, and especially between the altitudes of 10 to 30 kilometers, where there is no in-situ data available.
So we need to know the winds in remote areas such as the oceans because those winds in those areas determine what the weather will be downstream in, for example, over well-populated areas such as Europe many days later.
To address this need for more accurate global wind profiles, ESA will soon launch the Aeolus Earth Explorer satellite, with the ECMWF processing the data. If Aeolus can deliver the long-awaited wind data, meteorologists hope more satellites like Aeolus will be launched in the future. For numerical weather forecasts, it's important to have accurate wind measurements today to predict the weather tomorrow.
We have been picked up, or we're going momentarily to be picked up by the new Norcia. Am I saying that right? New Norcia?
Yeah.
Station in Australia, not far from where Aeolus is going to be separated, by the way. She's going to be separated off the coast of Australia, I do believe.
Acquisition de la télémesure lanceur par la station de New Norcia.
And the DDO has just announced that the signal has been picked up there. Now, just a word about the space base. The French chose the French Guiana site when they wanted to build a new site in 1964. There were many possibilities, including Australia and Scandinavia. Kourou got the nod because it got a lot of advantages. A large opening on the ocean, a low population density, nearness to the equator, and nearby hills where you can put installations for radar and telemetry. And you're looking at shots of the nearby hill where the CVI, also called the Real-Time Visual Center, is located right here. There's a lot going on there. These buildings are located just behind us here in Jupiter, in Kourou. And the hill is called the Montagne des Pères, the Mountain of the Fathers. Now, these teams are analyzing the data as it comes in from all the ground stations along Vega's flight path. Remember, we've been talking about Saint-Hubert and the Bermuda Islands and all the rest. These data are then treated to reconstitute the entire mission. And after that, the entire flight is recreated in figures from liftoff to well after satellite separation, then analyzed again in delay time. So all that to say that Arianespace has a huge amount of information in its archives. How each launcher, going back to the first Ariane 1, Christmas Eve 1979, remember, has performed. The first UV laser, that's something that you wanted to talk about. Now, what is that? That's part of the light of the Doppler?
Yeah, exactly. We are the first spacecraft that brings its own light source in orbit.
Okay. The DDO has just called out the second ignition of the Alum fourth stage. That's going to last for 20 seconds. Go ahead, sorry.
So it's also something that Anders Elving, the project manager, has said in one of his videos, is that we are the first spacecraft to bring a light source on board. That's not done before. And it's quite unique in the sense that we emit our own light.
And the DDO has just called out the extinction of the second burn?
Okay, good. So we have our own light source, we emit and receive.
Manœuvre d'orientation avant le booster RAX.
Oh, sorry, I thought I had to wait. So, and this is a first. So all the other agencies and programs have tried it, and they stopped because of all kinds of difficulties, because the laser is so powerful that you get all kinds of issues.
We are coming up on separation in under a minute. Can I ask you what's going through your mind now? Are you as emotional as you were at liftoff?
Well, this is going to be the moment that Aeolus will stand on its own to become an adult and go to work.
She's already an adult if she's 20 years old.
Yes, a young adult.
Yeah, or an old adolescent.
Yes.
All right, so you're feeling good.
I'm feeling good. Yeah. I'm feeling still a bit emotional, and it's quite strange, the feeling, and looking forward to the Solar A deployment later on.
All right, this is, for Martin as for all of us, a moment of high concentration here in Jupiter and, of course, elsewhere around the world for the Aeolus people as we await separation. Everyone be focused. We've gone through separations before, but it's never quite
Et séparation Aeolus.
Now there's the scheduled separation. You hear the applause. You can see the people smiling. That's the scheduled separation. Looks good. Assuming we're going to have to wait until confirmation, of course, when we get the signal from the Troll station in Antarctica, but let's assume that all is well. So congratulations.
Thank you, Joshua.
Your work is just beginning, or is it over now?
In essence, it should be over now because it's being taken over by our colleagues in ESOC. If they need me, it means that they have an onboard problem. So let's hope.
So that they don't call you.
Exactly.
Okay. We are waiting for confirmation, as I mentioned, confirmation of the acquisition of the signal from the Troll ground station in Antarctica. We want to wait for full confirmation just to see if separation has occurred properly, that Aeolus has been sent on its proper orbit, that its solar arrays are going to be in a position to be properly deployed, that the satellite's overall health is good. A few important items, I imagine, that you have to check before we can let the satellite officially start its life and work. Arianespace and ESA, of course, taking no chances, being very thorough. While we're waiting for the information to come in, here is another play. There will be a third avant burn, which is usually the case. We won't see it. It'll be in about 2 minutes. It'll be of about 2 minutes, I should say. It'll be for passivation. You know about passivation? That's when it takes place at a much higher altitude, and the what's left in the fuel of the upper stage tanks are emptied. So the satellite poses no danger to anything. That's another avant burn to put it into a slot there. But again, we won't see that. And also looking ahead, there will be a first post-flight analysis of the mission. We mentioned the archives that Arianespace has. That'll be held in the afternoon at the CVI, the Real-Time Visibility Center we saw earlier. There will be a technical review and a final post-flight review. On the phone, Anders getting his information from downrange, I imagine. There will also be a post-flight analysis meeting, usually at Arianespace headquarters outside Paris. So we're still waiting for the official confirmation of proper separation and the signal. Maybe it's Anders that will be giving us a thumbs up. Is he the one that gets the signal?
He should get the signal from CBL3, from our colleagues in S5.
Because Anders, of course, the satellite mission director, also known as the project manager. While we're waiting, we're going to go to Andres for a look at Aeolus's first maneuvers after separation.
So I'm very excited standing here after such a successful launch and separation of our Aeolus satellite. I'm looking back to a very successful launch campaign, cooperation with the teams here in CSG, CNES, ESA of course, but also the Arianespace teams and other launcher supplier teams, and we have worked very closely together with a very strong cooperation and will to reach this success. We have arrived 7 weeks ago by boat from Europe, and since then fueled the satellite and moved it through the various facilities here with ultimate cleanliness requirements and very high handling care to ensure that the satellite maintains its performance. So after this exciting news of separation and first link confirmation from New York, I'm looking forward now to the satellite carrying out its automatic sequence with all the actions, including the solar array deployment, and that will take about 90 minutes. From there on, our colleagues in ESOC, the Operational Control Center in Darmstadt in Germany, will take control and bring the satellite into a mode of safe behavior and stable behavior and that takes about 3 days. After that, we will move on to switch on the instrument, which is really the purpose of the mission, to create these wind profiles, and that will take quite a while. It's a complex instrument. We need support from many suppliers expertise on that instrument, and by the end of the year we hope to have commissioned the whole satellite, including the instrument. Then we can start delivering high quality performance data to the end users, which is the weather predictors and the climate research people throughout Europe and the world. Thank you.
The satellite solar arrays should be deployed very early. For me, I've never seen it so early. An hour and 45 minutes after separation. Usually with commercial satellites, this sort of operation takes place 4 or 5 days after separation, or a week. Now, this is for a reason, because Aeolus can't fly too long without the batteries. Is that it?
Exactly. So Aeolus has got relatively small batteries compared to the telecom programs.
Not as much fuel in the tanks, smaller fuel tanks, and smaller batteries.
Exactly. And at the moment we are running on internal power, so on the batteries.
Since minus 10 minutes.
Since minus 10 minutes. So we need to make sure that the arrays get deployed and that we got power on the bus.
Okay, while we're waiting for that and confirmation, we're take a look at the next video, a restful picture postcard with some more shots of the drone. Well, it looks like. Have we had confirmation? No, we're looking. We see some smiling faces. We're still waiting for the official word. Meanwhile, we hope you enjoyed the restful, peaceful picture postcard with music and our drone shots. Did you want to say anything to your friends, or you want to wait for confirmation?
Let's wait for confirmation.
I think that's wise. Nine more Vega missions and Vega C missions. Vega C, of course, the updated version. Is that it? Looks like we have confirmation. We have confirmation. We have mentioning 9 more Vega missions and Vega C missions. Vega C is the updated version, due to fly the first time next year. C for consolidated, I do.
I think it is, yes.
Vega C. 1/3 of those missions are for European institutions, 2/3 for export customers. Vega C development proceeding on schedule. Maiden launch next year. The new version offering higher performance, flexibility, handling an even greater variety of missions, and maybe your next missions, which include what, Flex?
Flex, for instance, yeah, that's the next mission after. That's the next Explorer that we're going to develop after Aeolus.
Is that where you go after Aeolus?
I will go after to Flex, indeed.
And this was the longest mission that you've ever worked on, is that true?
Yeah, it's been 8 years. It's been the longest project I've worked on in a row, and the last 2.5 years I've been following the spacecraft during the whole test campaign. And it's been a wonderful ride with a wonderful team, both on the industry side and ESA. And it's going to be a hard time to say goodbye to everyone.
Darmstadt, the pictures on the right, that's ESOC, right?
That's ESOC. That's where half of our project team is at the moment. Where on the left you see with the blonde hair and the curly blonde hair, that's Frank de Bruin. He's
Hello, Ms. Brown.
Frank, no, it's a guy.
Oh, it's a guy. Terribly sorry. Can't see anything on the screen.
Okay.
It would seem that we're still waiting for confirmation. You agree with me?
I agree with you.
This is another milestone tonight, the 50th mission launched by Arianespace for ESA. And there's some other very interesting ESA science missions coming up in the Arianespace backlog, including Bepi Colombo for October. Bepi Colombo is mankind's first mission to Mercury. We've been to Venus with ESA probes, and to Mars, and to asteroids and comets. This will be the first one to Mercury. Very exciting mission for October. Then there's the James Webb Space Telescope. That'll go on an Ariane 5. That's a joint mission with NASA. And a Soyuz mission for Cheops coming up also. Still waiting for confirmation. After confirmation, we will, of course, go to the post-launch speeches. We'll be hearing from Stefan Israel, CEO of Arianespace. From ESA, we may be hearing from Joseph Aschbacher again, or we may be hearing from Jan Werner by video, by Skype.
Indeed.
I'm not sure. One of those gentlemen for sure. We'll also be hearing from Mathilde Royer-Germain of Airbus, Defence and Space. So all that's ahead. As soon as we get confirmation of the signal acquisition from Troll, that's the station in Antarctica, just making sure that all is well. Earth observation satellites, let's talk about the market, because I think it's a very interesting market. Do you have any idea, any thoughts of where the market is going? Are the satellites, Earth observation satellites, getting bigger, smaller?
It's a bit both ends. We have quite large spacecrafts which we built in cooperation with EUMETSAT, like the METOP.
METOP, yes.
METOP. There's even the METOP-C, who is currently here in S1, which is due for launch on the 6th of November.
Yes, that's a Soyuz, I think.
That's a Soyuz launch, indeed. It's the first METOP from the first generation is being launched from here, because the A and B model were launched from Kazakhstan.
From Baikonur.
From Baikonur.
Right. Okay. So, well.
Oh, that's a relief. Het is gelukt, jongens.
Well, the picture says it all. No need for any extra commentary. What's your message to people back at ESA?
Back at ESA, guys, well done. It's our baby is in your hands now. En iedereen in Aztec, allemaal hartstikke bedankt voor de support. En ik zie jullie allemaal gauw.
So after nearly 20 years, 2 decades of development and technical challenges, one after the other, Aeolus
is alive.
Beginning her life, on her way to orbit. So where do you go from here?
I go back to Aztec soon, and then I'm heading all the other PAs who are working in the Earth observation program to help them do the same thing we've done here for Aeolus.
And you go to the FLEX program?
I go to the FLEX program with an instrument called Florus.
Tell us about that.
That's an instrument that's going to measure the plant health life from orbit.
Oh, good for crop and climate and weather, I imagine, also?
Exactly. The idea is that we're going to measure the plant health life, whether it's sufficiently wet or whether it's too dry or whether someone has used some chemicals.
Oh, very good. Very good. And then, of course, going into sun-synchronous orbit, I imagine.
Similar type of orbit, indeed.
All right, we're waiting for the first of the speeches. Stefan Israel will be making his way, he has made his way out from the fishbowl onto our side. He's making his way to the podium, and his voice will be the next you hear. Stefan Israel, CEO of Arianespace.
Okay. Ladies and gentlemen, distinguished guests, Arianespace is delighted to confirm that Aeolus has been safely separated on its targeted sun-synchronous orbit. Congratulations to all. Complimenti. Aeolus will precisely monitor wind flow and air currents on Earth, improving weather forecasting and ultimately our ability to protect the environment. Aeolus demonstrates how assets in space can help to preserve our planet and how Europe can contribute to this critical mission. I wish to thank the European Space Agency and especially Joseph Aschbacher, ESA Director for Earth Observation, for having entrusted Arianespace with such a key mission. Let me also highlight that tonight's launch is Arianespace's 50th mission for ESA, ensuring reliable and independent access to space for Europe is our first mission. It would not be possible without the long-term partnership between Arianespace and ESA. In this regard, I want to thank Jan Werner and reassert how grateful Arianespace is to ESA for this close collaboration. Another very close teammate of Arianespace deserves our congratulations, Airbus Defence and Space. Aeolus is the 120th satellite built by Airbus and orbited by Arianespace. We've got also 20 other Airbus satellites in our backlog without taking into account OneWeb constellation. Thanks to Mathilde Droyer and Jean Dauphin to be with us tonight, and congratulations for this key satellite. For its first flight of the year, the 12th time since its introduction in the CSG, Vega performed flawlessly. Today's mission demonstrated once again the great performance and flexibility of Vega. Let me congratulate all our Vega partners, ESA launchers and especially Daniel Neuenschwander and Stefano Bianchi, Thanks also to the member states of the Vega program, notably Italy, who plays a key role with ASI. Of course, let me express my deep gratitude to Avio, our shareholder and industrial prime for Vega. Congratulations to Giulio Renzo and all the Colleferro teams for this new success, which is absolutely remarkable. 9 more launches are already in our backlog for lightweight vehicle. 3 of them will be delivered by Vega C, which will be available by N29 to further enhance the flexibility and competitiveness of Vega. Last but not least, let me thank those who made this launch a success here in the Guyana Space Center. CNES, our contractors in the European spaceport, and all employees at the launch facility. Of course, I would like to pay my tribute to my team, to Arianespace colleagues, for this 5th launch of the year. And now I leave the floor to our customer. Jan Werner is going to be with us. Thank you very much. Thanks a lot.
Jan Werner, I'm now here in the control room at ESOC in Darmstadt, and I can tell you it's really very, very impressive for me. This time I was not in Kourou, and I can tell you the last 2 days were really stressed for me because I could not go to Kourou, and I thought, okay, if you are back here only in Europe, you will be relaxed, but I can tell you, no, it was not. And also the delay, the postponement due to wind, for a wind mission, but that was a very special thing. That was very difficult for me. But now to see that the satellite is working, of course we need some more tests in the coming time, but this is really a great moment. I'm really happy and my heart is beating, because it's never routine to send a satellite in orbit. This is really the masterpiece of many engineers, of scientists, of course supported also by the agencies, supported by industry, supported especially also by the taxpayers and the politicians. So I'm very glad that we have this mission, part of our Earth Explorer missions, and I hope that Aeolus will provide data which leads then also to some operational satellites for this area of wind measurement in the future. So congratulations to the whole team, congratulations to Europe. It's a European success.
I am very honored to be here today and celebrate the successful launch of the Aeolus satellite. As Joseph mentioned before, Aeolus is part of the ESA Living Planet program, a program Airbus has largely contributed to, with missions like GOSI, Cryosat, Swarm, and in the near future, Healthcare. But Aeolus is a very special mission. It is a world premiere. For the first time in history, we will be able to acquire wind profiles on a global scale from space. These first global patterns of wind behavior at different altitudes will help improve worldwide weather forecast and contribute to long-term climate research. This is where space provides us new means to understand our environment and better apprehend our planet. As you can imagine, such a pioneering mission was not a walk in the park. The development of Aeolus, especially the complex UV laser system of the Aladdin instrument, was a huge technological challenge. I would like to thank the European Space Agency for trusting Airbus on such an important mission, and extend these thanks to all the companies of the consortium that have helped us achieving this mission. What we celebrate tonight is the result of years and years of dedication of highly skilled women and men who never gave up. It is the result of outstanding teamwork all across Europe. I want to pay tribute to and give thanks for all the teams who made it a success, especially the Airbus teams in the UK, who primed this mission, in France and in Germany. You can be proud of what you achieved. Some of these teams are with us tonight here in Kourou. Some of the teams are participating to this launch event via video transmission in Toulouse and in Stevenage. So bonsoir Toulouse, hello Stevenage. You see, Aeolus is a truly European success. It is a great example of what Europe can do when teams cooperate across countries, when there is a shared will to make it happen. So let us celebrate all together in Toulouse, Stevenage, here in Kourou and everywhere. Again, congratulations to the teams and Godspeed Aeolus. Thank you.
So ladies and gentlemen, dear customers, I'm very happy to tell you that ESA will soon be back in the Guyana Space Center. It will be in October with Ariane. It will be for BP Colombo, and you can imagine how excited we are to launch BP Colombo. And before, if you allow us, we will have commercial customers for the 100th Ariane 5, which will be the 300 missions, 300 launch delivered by Arianespace. It will be in September, and it will be for Intelsat, SkyPerfect GSAT, and Azer Cosmos. Thank you very much, and enjoy the evening. Thanks a lot.
So from the terrace here, after the successful launch of that, will do it for us from Kourou, where the big news is that Arianespace Vega has once again delivered Aeolus, and on Vega's 12th mission, successfully delivering the Aeolus satellite.
Moi, je veux dire bon vent à Aeolus parce que
good luck to Aeolus. I know that now I'll be looking at the sky during the next 3 years and thinking about Aeolus up there at 320 kilometers altitude. So I say well done to all the teams, and I'll think about its ultraviolet laser and think about its fantastic equipment. Donc,
Earth observation mission, a success, carrying Aeolus, the wind profiler, beginning her life tonight, making her way toward her final orbit, where she will probe the atmosphere and provide data to improve weather forecasting and to improve climate research, to help us better understand the dynamics of the atmosphere and the energy balance. A very, very important mission. Congratulations to everyone involved.
ce qui est formidable ici, Josh.
Great here, Josh, and it's true every single launch that is, there's a sort of adrenaline that sort of starts to grow. There's a really thrilling and exciting atmosphere. That's something so wonderful about this space adventure. So all the teams know what I'm talking about. So stay faithful to Arianespace. Keep watching our launches from the CSG and be with us as often as possible and as long as possible. And I forgot to say that I have to put my hat on. So now...
Proper goodbye. Our next flight As Stefan Israel mentioned, September 10th, that's the 100th Ariane 5 and the 300th mission of a member of the Ariane family. That's a couple of big milestones. You won't want to miss it. We'll be here. We hope you will be too. So until then, on behalf of everybody here at the Space Base, Pierre Junier, Joshua Jampel saying thank you for being with us. We hope you enjoyed it. We certainly did. And we look forward to being with you next time. Goodbye, everybody.
That's for sure, Josh.
Yes, we celebrated the 50th year of launches from the CSG, so the next flight will be the 100th launch of an Ariane 5. Can you believe it? The 100th launch and the 300th launch of the launch family of Ariane 5. So I think these figures speak for themselves. I will do exactly like Josh. I will wish you all an excellent evening and goodbye to all and see you very soon. Bye-bye.